The question says 25 ml of 0.1 molar solution of a stable cation of transition metal Z is there. Transition metal Z is there. Okay. Reacts exactly with 25 ml of 0.04 molar acidified KMnO4 solution. Acidified KMnO4 solution, in the sense reaction is taking place in acidic medium. And now pay attention carefully. It says which of the following is most likely to represent the change in the oxidation number या oxidation state of zinc correctly. अरे zinc नहीं Z है भाई, Z correctly. Okay, ठीक है. So now keep in mind KMnO4 is a strong oxidizing agent, and definitely there will be change in oxidation number of Z. Why? Because it is supposed to undergo oxidation in the presence of a strong oxidizing agent. How the reaction is taking place? See, we have Z is there, okay, and plus it is in the neutral form, present in neutral form. Single metal is there, means it has a zero oxidation number. And it is reacting with KMnO4, and keep in mind this reaction is taking place in acidic medium, so KMnO4 will always convert into Mn2 plus in acidic medium, and then we have Z, and it is what X is there, okay, and that new oxidation number, it is unknown, so I assume it is X. And definitely since it is undergoing oxidation, Z is undergoing oxidation, so there should be increase in oxidation number, means whatever the value is coming, it is supposed to be greater than 0. Okay, so we can say X is greater than 0. Okay, very interesting concept. Okay, X is supposed to be, whatever the value of X we are going to calculate, it is supposed to be greater than 0, because it is undergoing oxidation in the presence of a strong oxidizing agent. Okay, so you can see the data is talking about these two substances, so we can equate their molecules. Okay, we can equate their molecules. So we have number of molecules, number of milli equivalence of Z is equal to number of milli equivalence of KMnO4. And if we apply the concept of molecules, we need to get the n factor value. Okay, n factor value. Okay, so because number of molecules is equal to what? Millimoles multiplied by n factor. Okay, let me write. If you want, you can see we have number of molecules. Let me remove this portion, need some space. So we have number of molecules. Number of molecules will be equivalence is equal to millimole and multiplied by n factors. And if molarity is given this, you have to apply molarity multiplied by volume in ml and multiplied by what is that? N factor value. Okay, very interesting. So n factor value for KMnO4 we can calculate. Write down the oxidation number. 4 to Z, potassium is what? Plus 1, then plus 7 oxidation number. Other side Mn2 plus is there. It is Mn2 plus. Find the difference in oxidation number. Difference in oxidation number will give us the n factor value. Say 1 minus 2 is equal to 5. N factor value for KMnO4 is what? 5. Okay. For this we cannot calculate because that oxidation number is unknown. Okay. So n factor we can calculate. N factor we can calculate for this substance. Okay, so for Z, you can see for Z, what is the data given there? Z, you can see, okay, volume and molarity is given this. Of course, we are going to use this formula. Molarity multiplied by volume multiplied by n factor value. Okay, so first one, molarity is for the Z. What is given there? Molarity is 0.1. Very interesting. Okay, then volume is given there 25. For Z, we don't have the n factor value, so directly I write NF. Okay. Other side for KMnO4 molarity, what is the KMnO4 molarity? 0.04 multiplied by volume. How much volume? 25 is there, and then multiplied by what? N factor. For KMnO4 we calculated n factor value is 5 is there. Now let's simplify. Need some more space. Okay guys, now we can get 2.5. Better, why we need to multiply? I do one thing, because 25 directly cancel, then we have n factors is equal to 0.04 multiplied by 5 and divided by 0.1 is there. Okay, 5 4 20 will be there, so this is what 0.2 and divided by 0.1 is equal to 2. N factor value we got 2. Okay, for what? Zinc. That is Z, transition element. Okay, that is transition element is there. Okay, for Z we got n factor value 2. Okay, how we calculate n factor value? It is the difference in oxidation numbers. So you can see whatever the value of X is supposed to come here, it is supposed to greater than 0. And when we find the difference in difference in oxidation number of these two values, it is always supposed to be 2 because n factor value we are getting 2 anyway. In any of the option in which there is a difference in oxidation number that is 2, means that will be the correct option. Okay, so let's calculate. Plus 1 and plus 2, 2 minus 1 is equal to 1. No, it is not correct. Plus 2 and plus 3, 3 minus 2 is equal to 1. It is not correct. Plus 4 and plus 3, 4 minus 3 is equal to 1. It is not correct. Plus 4 minus 2 is equal to 2, and factor value we are getting for this, it is 2. Then it is correct. Option D is correct. Very interesting question.